Hello and welcome to the Story of Rivers webinar series from the South East Rivers Trust. The South East Rivers Trust is a grassroots environmental charity dedicated to improving rivers across the southeast of England. This is episode 8 in the series and it's all about natural flood management. If you want to catch up with any previous webinars, then they are on the Cert River Club Facebook page and also on our YouTube channel. If you have any questions at all at any point during the webinar or afterwards, please just type them in the Facebook comments below because it will help us to do some question and answer sessions with our panel of experts staff. So I'll hand over to Ed and Dean now to introduce themselves and to present the rest of the webinar.
Hi, I'm Ed Byers. I'm a project officer at the South East Rivers Trust where I've been working for 2 years. I've got a background in flood management over a number of years, and I'm involved in a range of projects with CERT, including natural flood management, sustainable drainage systems, and river restoration.
Hi, I'm Dean Morrison. I'm CERT's NFM, or Natural Flood Management Officer for the Medway. I've got a background in countryside management. I trained as an ecologist, and I've worked for groups like Kent Wildlife Trust, the Environment Agency, and the British Trust for Conservation Volunteers.
Okay, so today we're going to talk about what is natural flood management, how does it work, examples of natural flood management techniques, and some case studies of NFM in the Medway catchment. So firstly, why do we need flood management? Well, flooding is a natural process of a healthy river. However, it can also have devastating impacts on communities. And this is exacerbated by development in a river's natural floodplain, which has happened over hundreds of years. Secondly, modification of the landscape, such as compaction of soils, cutting down trees, adding in artificial drainage and urban development, has also resulted in less infiltration of rainfall and more rapid runoff. This leads to greater volumes of water reaching the rivers more rapidly. Historic straightening and dredging of river channels and removal of fallen trees speeds up the flow of water downstream. These changes can cause flooding directly from surface runoff or from greater flows in rivers. Finally, climate change is predicted to result in much more extreme rainfall events, leading to more frequent and severe flooding events. In turn, drier periods are expected in between these rainfall events. This results in communities being vulnerable to flood events, possibly on a more frequent basis in the future. This is why we need flood management, to protect people and their livelihoods, as well as key infrastructure. So what is natural flood management? Well, before I get into that, I'll talk about what is often called traditional flood management. Traditional flood management involves constructing heavily engineered flood storage areas and walls, which are frequently situated downstream close to where flooding occurs. High flood walls can be constructed in villages and towns to keep floodwaters constrained within the river channel, preventing it from flowing out of its bank. This can potentially protect communities from larger storm events. However, the disadvantages of this approach are that this can speed up the flow of water downstream, potentially impacting communities further down the catchment. Whilst this is very rare in the UK, flood walls can fail or be overtopped, which could result in much more devastating flooding as the water level has to be raised up. Both flood walls and storage areas can be expensive as well as intrusive and therefore can't be employed everywhere. Natural flood management, on the other hand, is a different way of trying to reduce flood risk, tackling the problematic source, the landscape upstream of at-risk communities, whilst offering multiple benefits to people and wildlife. As I mentioned earlier, we have modified our landscape drastically, and this often exacerbates flooding downstream. Natural flood management looks to restore and enhance the natural landscape processes to hold water back in the landscape and slow down its flow downstream. A key component of natural flood management is working at the local scale to understand the landscape and how we can work with and enhance natural processes for flood management. It's also about working closely with landowners to understand how they use their land so that natural flood management can be sensitive to this and where possible provide benefits not only to communities downstream but to the landowner too. Natural flood management is all about offering benefits in addition to flood mitigation. It involves a number of techniques which Dean will talk about later in the webinar, but they include examples of leaky woody structures, floodplain scrapes and storage areas, creating wet woodland and storing water, creating shallow bunds to intercept runoff, planting riparian and catchment-wide woodland, blocking small drainage channels, fencing off woodland to prevent compaction of soils by livestock, improving the soil structure, and creating small ponds and storage areas. As mentioned before, natural flood management, unlike much traditional flood risk management, can offer multiple benefits. These will be discussed later in more detail, but they include creation of new habitat or restoration of existing habitat, amenity, improvements to farming, and improvements to water quality. So how does natural flood management work? Well, as mentioned before, natural flood management is all about slowing the flow of water downstream so that it doesn't all arrive at the same time. A good analogy for this is the morning commute, which a lot of people will be familiar with. For example, if everyone in the southeast who has to drive to London for their morning commute set off at exactly the same time, the first part of their journey from small villages and towns might be relatively smooth and fast. But when they join the major roads and bottlenecks and encounter more people along the way, they encounter traffic jams. If, on the other hand, people set off at different times, and perhaps there were some obstacles along the way, such as speed bumps and traffic lights to slow things down, then the overall flow of traffic would be smoother, as the traffic downstream has a chance to get to its destination before the next wave comes along. This essentially is what natural flood management seeks to do with water. By holding back and delaying flow in the minor tributaries, we can relieve the buildup of congestion, in this case flooding, downstream. This figure shows this concept of how natural flood management can impact the flood hydrograph. The hydrograph shows the amount of water passing a particular point, in this case a river where it passes through a town over a period of time. The blue line shows the hydrograph for a modified landscape during a storm event. We can see that during a storm event, the flow in the river rapidly increases as water rushes off the landscape and flows quickly downstream along straightened streams and rivers. Water passes through the community in one rush, causing the river to overflow its banks and flooding properties. Natural flood management aims to flatten this sharp peak, spreading out the arrival of water downstream by storing it and slowing it up in lots of areas of the catchment. It's all about numerous small-scale measures which are sensitive to and work with the landscape, as opposed to large engineered flood storage areas, for example. Current thinking suggests that natural flood management is suited to relatively small catchments and during smaller flood events. This is because as the size of the catchment increases, the relative impact of a single natural flood management measure decreases, meaning that we need a lot more NFM measures. Similarly, for very large storm events, there's simply too much water in the landscape. It is also important to understand that flooding is a natural process occurring in even an unmodified landscape. Therefore, in areas where we've built on the floodplain, flood management of any kind may not be enough to protect properties from every storm event. Natural flood management can therefore be complementary to traditional flood defences, helping to ease the strain on them, or for mitigating the impact of future climate change, or in smaller catchments where hard engineered flood defences are not feasible or just too expensive. Finally, just imagine if we adopted NFM into the everyday management of the landscape, thinking about how we can work to improve natural processes while continuing use of the land to produce food, for recreation and many other uses. This might be planting more trees, improving our soils and creating small temporary ponds all over our landscape. We might start to see really big differences in flood risk and many other benefits to nature and livelihoods.
CERT has been given a great opportunity to trial some NFM work in the Medway catchment in the southeast. The origins of that project come from some terrible flooding that happened in 2013 when the Olding in particular and towns and areas down at the bottom of the Medway were severely flooded, causing quite a lot of economic damage as well as kind of damage to people's properties. So a lot of organisations then came together after that and decided to look at how we could tackle flooding in a holistic way, bringing together all of the agencies and different bodies that have some interest in flooding, from the Environment Agency to Kent County Council and others, and especially local communities, to tackle the problem, not just using the traditional kind of techniques of flood management, but looking at how communities can help protect themselves against flooding, and in particular to look at natural flood management as something which could complement everything else. So that's a really important part of our work. We're part of a jigsaw of tackling flooding. And we're also working on a European level through a thing called the Frames Project, looking at flooding across Europe and how we can tackle flooding from start to finish just to reduce the effects of it. So the aims of our project, we need obviously to deliver some tangible flood reduction benefits for people. Well, one of the great interests for us is that through natural flood management, we can, as well as protecting people's properties from flooding, we can actually improve the quality of rivers and do the kinds of things that South East Rivers Trust are obviously very interested in. And we kind of wrap that under talking about multiple benefits. So we can provide benefits for biodiversity, for public amenity, and very often for landowners as well, helping them manage their land in ways that benefit them. So we get win-win-wins all down the line. Now, NFM has been something that's been trialled across the UK in different areas, but every area of the country is very different. So what we've needed to do is to find out what will work here down in the southeast, particularly in the Medway, to find what's appropriate, what will work best, and what will work best with particularly the local land ownership kind of background we've got. We've had to work out how we can make these structures safely. That's a really important thing. Obviously, we don't want to be causing flooding, which is possible theoretically. If we create, we'll talk about leaky woody dams later, if they wash out and block up culverts, you could actually cause problems, and we don't want to do that. So developing the techniques which are safe is important. It's also very important for our landowners. And then overall, we want to monitor what we do. NFM is a new area of work for everybody. We kind of pretty much all believe it works and makes a contribution, but how much, where to do this best, and how to go forward, it's very important to try and build a kind of a scientific evidence base for this. So one of the big objectives of our project is to contribute to that, and Ed's been doing a lot of work on that. So just to talk about those multiple benefits a little bit more, in this slide you can see this is one of 3 ancient woodlands which we're fencing alongside a place called the Oldest Stream, which causes flooding in a local community called Five Oak Green. And this is an existing piece of woodland. On the left you can see where it's a neighbouring landowner has fenced off some of the woodland from sheep, and you've got obviously a rich ground flora there full of bluebells and ferns and lots of other things, very good for biodiversity. On the right of the fence is the same basic woodland, but where the sheep get at it, and sheep and cattle. And you can see they damage the woodland floor, which causes flooding problems because we get very rapid runoff. The water doesn't sink into the clay soils because they're all compacted. And you also wash off silt and sediment into the river, which isn't really good for water quality. And for the farmer as well, his animals get lost in that wood, and he's trying to round them up, and it's almost impossible to do that. So from an animal welfare point of view, it's very good to fence off these woodlands. So through the project, we've managed to fence off 3 woodlands over probably, I think, 5 or 6 hectares, which helps provide those multiple benefits, and very importantly, we think, by slowing the flow of water, provide flood benefits. Now we'll come on to one of the kind of major opportunities we've got in the Medway. Very kind of central technique in natural flood management is creating what we call leaky woody structures. Some people call them leaky woody dams or beaver dams. There's various names for them. The current kind of thinking is that we should call them leaky woody structures. And what these are kind of temporary dams which slow down and hold temporarily, even just for a few hours, hold up the flow of water before then releasing it and let the river do what it normally would do. So in normal conditions, these structures do nothing. They just let the water flow along its natural course, but in a big downpour with a great big spate, they'll hold back and kind of put a brake on the whole system. One of the great things for us in the Medway is the Medway is a large part of it is the Weald, which has got the highest concentration of ancient woodland in all of the UK. So it provides us with lots of opportunities to go and do this work. As I was saying, safe and effective design is essential. During the project, there was some national research that was released about how you can build dams, leaky woody structures very carefully, where you don't build them because they create higher risks near culverts and bridges and things. There are aspects like using very long timbers, which even if they kind of wash and they move a little bit, they don't ever very go far. We call them functionally immobile. So if they're 2.5 times the length of, or the width of the watercourse, they're pretty safe to put in. And another important aspect has been working with local woodland contractors. We've got a thriving woodland sector in the Weald, and using their local knowledge about how to do this stuff. And one of the other things we try to do as part of that is we use willow and poplar wherever we can in our work, because we put this in water, it will take root and provide very long-lasting, stable, self-sustaining structures, which is obviously great for us. This isn't a strict divide, but I've divided, for the purposes of the seminar, our leaky woody structures into small ones and bigger ones. There is the principal difference is that we've got lots and lots of opportunities to do lots and lots of small things. The bigger things are kind of, you know, we don't often get the opportunity to do them because the number of streams are smaller. I think the conclusion is we need to do both of these types of things. So with the small ones, and here are some examples, we put these right up in the headwaters. It has the advantage of slowing down the water flow from the very, very commencement of the cycle. So you buy more time by stopping the water at source. And of course, they're quite cheap to put in. We can use volunteers to put them in. They're very low risk. So that's something that we've started with. They're also a great learning opportunity to work up to building the bigger structures. With our bigger structures, we're kind of gradually working downstream. We tend to need to use woodland contractors or our own skilled cert staff who are chainsaw trained, and to carefully design and build larger structures which won't wash out, they won't cause problems. They're more challenging to put in because you're moving bigger timbers in very difficult situations where you've got steep-sided clay, slippery slopes, and using lots of use of winches and sometimes machinery to do that. So we've worked on some of those in our courses, and we're putting our very biggest ones in at the moment. Here I've got a video of some of these in action to see how these things work. That's really what we want to know. Is this going to work? So one of the best things we've had the opportunity to do this winter with the amount of stormwater we've had is to go and take video of some of these things in action. So here's a short 1-minute video starting with some of the smaller structures and working down to the bigger ones. Most of these were taken during Storm Dennis, I think. So this is a small structure up in Medway. And very small structures can hold back a surprising amount of water if they're well positioned. This is on the RSPB Tudley Woods site, which belongs to the Hadlow estate. This is an amazing stream. It's usually flows as a very small trickle for most of the year, but in a storm it will come up 1 metre high and come down as a complete torrent. So by putting these larger woody structures in, we're able to spread out the flow and tame that very fierce flow that comes down in storms. So those great structures are just kind of making that flow of that water much more gentle and storing quite a lot of it.
Okay, so now I'm just going to give a quick case study of one of the NFM projects that we've delivered in the Medway catchment. And this is King's Node Pond, which is a brilliant example of the multiple benefits of natural flood management to both the landowner and the downstream community. The project's located in the School Stream catchment upstream of Headcorn in the Medway catchment, and involved restoration of an old pond, significantly enhancing local ecology, whilst also creating a flood storage area to take flows from the nearby stream during storm events. Once vegetation has grown back, it will also be a really beautiful area for the landowner to enjoy. I'll just talk through how the project came about, the work carried out, and how we're monitoring it. The first step in the development of the project was a desk-based assessment of potential natural flood management opportunities within the school stream. The process used satellite imagery, flow path mapping, NFM opportunity mapping to identify areas where it was thought possible to effectively slow down and store water. This included areas where overland flow paths could be intercepted or where large woody structures might be feasible. It allowed us to target engagement with landowners to understand their land and how NFM might fit into this. Kingsnode was identified as a potential area to kick water out onto the floodplain during high flows. A key step in developing the project was Dean meeting with the landowner to walk over their land and get an understanding of how they used it. The walkover revealed an area where water had historically collected, potentially an old pond or even maybe a small quarry. The area had, however, over time become overgrown, and the owners were at a loss as to what was best to do to improve the area. Due to the dense closed canopy, there was very little woodland ground flora. A survey carried out by CERT's ecologists determined the area was of limited ecological interest, with the ground surface composed almost entirely of decaying leaf litter. It therefore looked like there was a lot of potential to restore the function of the pond, and at the same time, a survey of the area and nearby stream showed it would also be possible to divert water from the stream during a flood event, temporarily store it in the pond, and then slowly and safely release it back into the stream once the flood wave had passed. The next step was to meet with the landowner's regular contractor to talk through the project idea and develop an outline design. The contractors had crucially worked with the landowner for years and so had a great relationship with them and knew the area well. And the contractor was also locally based in Headcorn and had experienced flooding there firsthand. This was a great opportunity to work with local people who understood the devastating impact flooding can have on the community. This is also important for spreading the message of NFM and the benefits it can offer communities and landowners. The work began in December 2019, starting with clearance of a number of fallen willows and stacking of deadwood to create habitat piles. Some tree thinning was carried out, taking care to reserve any trees which could have potential as bat roots. Importantly, work took place outside of the bird nesting season. Once the trees were cleared, excavation of the pond could begin. The work was hard going with tricky weather and ground conditions, with the site becoming something of a mud bath halfway through, as you can see here. However, once a thick layer of leaf litter was removed from the pond area, you could see everything start to really take shape. The depth of excavation was varied in order to create different depths of water within the pond and add more ecological interest. This will lead to a mix of permanent and semi-permanent areas of water. Finally, a low-grade bund was constructed at one end of the pond to stop floodwaters from flowing rapidly through the pond and straight back into the stream. This causes the water level in the pond to temporarily increase as water flows in from the stream, and then a small pipe was installed to allow the pond to drain in a slow and controlled manner once the flood peak is passed, allowing water levels to drop back to normal. One key aspect of the work we're doing is monitoring natural flood management, to get an understanding of how the measures we create are performing, and Kingsnode is a great example of this. This is really important to try to quantify the impact on flood risk downstream and to learn from each project to improve how we deliver natural flood management in the future. The great challenge at the moment is quantifying the exact impact on the downstream flood hydrograph, and therefore the level of protection provided to properties as a result of NFM measures. Because NFM is by its nature not heavily engineered and designed, it involves complex processes and is numerous and dispersed across the catchment. It can be tricky to monitor. However, by focusing on monitoring at the local scale, we can see whether natural flood management measures are storing and flowing water in the way that we want. Logically, if we do enough of this across the catchment, we'll start to have an impact on the hydrograph downstream. This is an example of the monitoring we're carrying out for the Kingsnode project. In contrast to the illustrated hydrograph we saw earlier, the graph shows water level in Kingsnode Pond and the adjacent stream during Storm Ciara. This tells us if we are providing effective flood storage. If the storage area fills up too quickly, it will be full before the peak flow in the river occurs, and therefore we won't attenuate the flood peak. Similarly, if it fills up too slowly, we won't have made the most of the storage area. By monitoring the project, we can make small changes if we need to, for example, changing the level of the spillway from the stream into the pond, or the diameter of the pipe draining the pond. You can see from the graph, this shows that the water level in the pond peaks at a fairly similar time to the peak in the river. We've also collected photos and videos of the pond during storm events, which is really important. And we can see that at its highest level, water was spilling out of the pond, which is likely to explain the water level initially dropping rapidly as the river level dropped. As a result, we may make some tweaks to improve the storage area. This highlights how monitoring is really important to just improve our technique. Overall, the project's gone really well, and it's estimated that the area can store 600 cubic metres of floodwater, as well as enhance local ecology. Importantly, the landowner is delighted with how the project's worked out and will be able to enjoy the area for years to come afterwards. We now want to find more places to create small storage areas similar to this, and keep increasing the benefits to downstream communities.
Thanks, Ed. We're obviously very excited about some of the projects we've done, and we're very encouraged by the things we've learned from NFM, and CERT generally would like to do more of this across the Southeast. So we've been getting support for our project and for potentially others in the future. We've had visits from the Environment Agency chief to Medway, which is a demonstration site. We get 200,000 visitors there a year, and we're putting up display panels, and we've got an education centre, so we're working with the Forest Commission to promote NFM there. We've also had a visit from the head of the Forestry Commission, and over at Sissinghurst we've got another demonstration site which again gets over 200,000 visitors, where we've created a similar project to Kingsnow, slightly bigger in scale, creating a water meadow which is publicly accessible with display panels. Our partners, our extensive partner network is promoting the project, and we've had a visit to one of our projects from Greg Clark MP, just shortly after the flooding from Storm Ciara, to work we're doing on the older stream. And he's incredibly supportive of the project now, along with the local communities there, very importantly. And they're all helping us promote the concept of NFM across the region, and hopefully, from our point of view, getting some more funding to do much more of this.
Thanks, guys. Just remember, if you have any questions at all, just type them in the Facebook comments below. We'd like to say a massive thank you to our funders and also our partners and landowners that worked with us as part of the Frames project. Next time on the Story of Rivers, we're going to be looking at invertebrate life in fresh water, so we can zoom in under the microscope and see what little critters we have living in our rivers. I hope you've enjoyed this episode of the Story of Rivers, and we'll see you again next time.